So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman. Welcome you all to a new and amazing video in which we are going to deal, or maybe we are going to we are just going to just have a look at the introductory part of the Bessel's function. Oh, before everything else, let me tell you, it's been a quite long time that we meet, but that we meet here on the YouTube actually, but actually I was busy somewhere. I was giving some exams, that's why. But it's all right. I'm back, and I will literally try to just bring videos consistently from now. Okay, so we are just going to deal with this one, right? Okay, let's just dive into it. Well, let me tell you, what's Bessel function? Well, it's the solution of Bessel's differential equation. So, um, the Bessel's differential let me tell you what's that, and then we'll talk about the Bessel's function. So that is x square times the double derivative of x with respect to y. I'm sorry, it's not like that. Oh, I just made an error here, but it's all right. So it's with respect to x, with double derivative of y with respect to x, and then it's plus x and then the derivative of y with respect to x, and that plus x squared minus n squared. Oh, wait a second. X squared minus n squared times y. Yeah. So x squared minus n squared times y equals 0. So this is your Bessel's differential equation. And the solution to this differential equation is the Bessel's function. And this is generally denoted with j of x sub n. So this is this is how we denote the Bessel's function. And the solution to this differential equation, this Bessel's differential equation, is, here it is. Oh, let me just write it down here. So let's suppose that the solution of this Bessel's function is this one, that is j sub n of x, and that comes out to be the series as r goes from 0 to infinity of -1 to the r over r factorial times gamma of n plus r plus 1 times x over 2 to the n plus 2r. So this is your Bessel's function. Yeah. So this is your Bessel's function, guys. And actually, this is the solution of this differential equation. So yeah, it's we can extract this from here itself, but we are not going to talk about that because that's quite difficult. Maybe, I'm not sure, but if your demand for this, I will surely bring a video in which we can derive this one from this differential equation. But I don't think so it's important. Or maybe if you want, just comment down. I will just bring a video on that separately, don't worry. Okay, so basically what we're going to do is we're just going to play with this, and we're just going to play with this one, this power, and then this x. So I think we should just continue here. So what we're going to do is let's check the how this changes when we talk about this x and when we talk about this power, this exponent. So let's talk about firstly this one. Okay, let me divide it in two parts. First, when n is even. So we're just going to talk when n is even, right? It means that this is even. Okay, just tell me if n is even and 2r will always be even. So basically this becomes overall even, right? And um, oh, well, let's just talk about we have j sub n of x as the sum as r goes from 0 to infinity of negative 1 to the r over r factorial times gamma of n plus r plus 1 times x over 2 n plus 2r. And if we replace x with negative x, here we're going to do that, and let's see what it evaluates to, like how it is related with this one. Let's see, and this is really exciting, guys. So when we talk about j sub n of negative x, be careful. So just you have to replace x with negative x here in this part. So you have to replace this x with negative x. So that's going to give us sum as r goes from 0 to infinity of negative 1 to the r over r factorial of times gamma of n plus r plus 1 times negative x over 2 to the n plus 2r. Okay, so as I just explained you that this is overall even because we assumed n as even. So this is even, right? Okay. Oh, tell me something here. When you just let's take a negative value, let's take a negative quantity, and you just take an even power of that. Let's say 4. So negative of that quantity to the fourth is just that quantity to the fourth, because negative 1, well, let me tell you. Let's say we're talking about negative z to the fourth. Okay, so this can be written as negative 1 to the fourth times z to the fourth. So negative 1 to the even is 1. So that comes out to be z to the fourth. It means that this is exactly this one only because this power is even. Okay, let's talk about this. So I can conclude this to j sub n of minus x is the sum as r goes from 0 to infinity of negative 1 to the r over r factorial of times gamma of n plus r plus 1, and this becomes x over 2 to the n plus 2r. Oh, tell me something here, fellows. Is this the thing that we have learned about earlier in this video? So what does that mean? When your n is even, oh, let me just use a different color, maybe if I have, yeah, I'm having something. So when your n is even, just be careful about this because this is where we started. So your j sub n of x equals j sub n of minus x. So this is what you concluded actually. You can see this right over here. This is your j sub n of x, right? This is exactly the same. So yeah, this is what we have concluded. How cool is that? Well, it's not that much cool actually. I'm exaggerating maybe, but actually it's easy to just see. And now we're going to talk about when n is odd. Let's talk about that. So if we erase all the stuffs, so they are going to disappear, but maybe they exist somewhere else in the universe because nothing disappears forever. Oh, let's not jump into uh, astrophysics actually. Okay, next we are going to talk on when n is odd. Okay, now let's talk about when n is odd. What about this whole power comes out to be? Let's say that your n is 3. So when you just have a look at this power, and when you just plug r equals 0 to infinity, so that's going to change us. The first would be 3, second would be 5, third would be 7, 9, infinity. So this whole power evaluates to, like, this whole power comes out to be odd, as you can see right over here. So hence this power is odd, and now we're just going to play with our Bessel function. That is, as r goes from 0 to infinity of negative 1 to the r over r factorial of gamma times gamma of n plus r plus 1 x over 2 to the n plus 2r. Okay, so replace x with negative x. That's gonna give us j sub n of negative x 0 to infinity of negative 1 to the r over r factorial, gamma of n plus r plus 1 negative x over 2 to the n plus 2r. Well, you can think of something here. When you are having something negative, let's talk about this z to the power of odd, let's say 5. So that can be written as negative 1 to the 5 times z to the 5. So negative 1 to the odd is just negative, so that's going to give us negative z to the 5. Or maybe if you have watched some of my videos that I have posted earlier, so you might have an idea about what are even function and what are odd functions. So from there you can also conclude this one. So this becomes negative, right? So how we can go with this? That comes out to be j sub n of negative x equals negative of this infinite sum, as r goes from 0 to infinity of negative 1 to the r over r factorial gamma of n plus r plus 1 x over 2 n plus 2r. Okay, and here again you can see something, that this is your j sub n of x, and from there you can prove that conclude here j sub n of negative x, well, this is important to be highlighted, equals negative of j sub n of x when your n is odd. Okay, so yeah, this is basics that I wanted to just show you in front of you all, and this was necessary actually. If you talk about the solutions that we should calculate to reach here, so it's doable, but I just don't want to dive into those things which I'm not properly understanding. That's the truth. I'm not gonna lie in front of you that I can do this, but I don't want to bring in front of you. Actually, I cannot do this right now, but I can make sure I will do this, and I will prove that this is the solution of this differential equation. Yeah, that's the truth. I don't want to lie here. I'm not genius. I'm not a genius actually. I'm just a learner. Yeah, that's what I think about myself. Okay, now let's talk about another beautiful thing. Actually, wait a second. Yeah. So let me just erase these stuffs. I'm not gonna lie because um, I can do that, but if I'm not having proper understanding of that, so I'm not gonna tell you over there. So yeah, but yeah, I will definitely study this, and I will definitely just bring a video on that for you all. Okay, so the another thing that we are going to do is we are going to prove something. Prove that limit as x tends to 0 of j sub n of x over x to the n equals 1 over 2 to the n times gamma of n plus 1, where n is greater than -1. So yeah, this is what we are going to prove here, and maybe this is going to be the last thing that we are going to prove. Okay, so before we begin our proof, let's reconsider our j sub n of x. What was that? That was this thing. Yup. Yeah, this is what it was all about. And okay, let's do something in this day. What we can do? I can consider this thing. Let me just do it here. So x over 2 to the n plus 2r can be written as x to the n times x to the 2r over 2 to the n times 2 to the 2r. Right? And since this x and 2 and their power are independent of x, so they can be factored out of this infinite sum. So that comes out to be x to the n over 2 to the n and times the infinite series as r goes from 0 to infinity of negative 1 to the r x to the 2r over r factorial gamma of n plus r plus 1 fact. Or we can write this thing as n plus r factorial maybe. Yeah, so it's not maybe, it's we are going to write gamma of n plus r plus 1 as n plus r factorial. If you are not familiar about this thing, so you can just consider my introductory video on gamma function. I have uploaded this on my channel. You can just check that out. Okay, and let's just write this down in factorial form. So n plus r factorial. Okay, and we are left with 2 to the 2r in I'm sorry. Yeah, and let's just expand this thing here on that board, and I'm just going to take the x terms one side, that is left hand side. So this is going to just come up here. So that's gonna give us j sub x over j sub x, sorry, j of x, sorry, j sub n of x, I'm sorry about that, extreme result, over x to the n equals 1 over 2 to the n. And let's expand this. So when you plug r equals 0, so that's gonna give us, this becomes your 1, and this becomes 1, okay, this becomes 1, and this becomes n factorial, and this becomes 1, right? Okay, so your first term would be 1 over n factorial. Let's talk about the second term. So that's gonna give us negative, because when you plug r equals 1, so that's gonna be a negative here. So that becomes x to the 2 over n plus 1 factorial and 2 to the 2, and then plus x to the 4 n plus 2 factorial, yeah, yeah, and 2 to the 4, and that just keeps up going to till infinity. Okay, so it's good. And now we are going to take limit as x approaches 0 on both sides. So if you take limit as x approaches 0, so that comes out to be j sub n of x over x to the n equals limit as x approaches 0 of 1 over 2 to the n, 1 over n factorial minus x square over n plus 1 factorial 2 to the 2 and plus dot 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 to infinity. Since this n and these two terms are independent of x, and when you plug x 0 in this thing, so these all parts are going to be 0. It means that this part is only left with you. That's what we want. That's what we needed. Or maybe I should write it on whiteboard actually. So limit x approaches 0, j sub n of x over x to the n equals, that comes out to be 1 over 2 to the n times n factorial, and n factorial can be written as 1 over 2 to the n, n plus 1 gamma, and hence proof here. Yeah, that's good. That was really cool. And I hope you learned something from this video. Thank you so much for watching this video, guys. And yeah, just keep watching my all of videos because you're going to learn a lot of things from my videos. Maybe it's up to you to learn or to. No, I don't need to talk about more on this. And yeah, just be patient. I will bring a lot of videos, and please comment below that if whether you want the descriptive video on the evaluation of this thing from the Bessel's differential equation or not. If you want, surely I will make a video and I will read about it. So yeah, that was all about Bessel function. It's not all about, it was slightly or maybe something about Bessel's function, but I'm thinking about to bring some videos on that. And yeah, thank you so much for watching this video, guys. Stay tuned. Goodbye.